distributive law with monomials. But first, before we get it to with monomials, let's remind ourselves of what the distributive law is. So the distributive law said that if we ever have some number outside of a set of brackets that's multiplying that set of brackets, what you can do is you can take that number and just multiply it by the individual parts inside the brackets. So in this case, you have the 2 out in front, so you could do 2 times that number 3, and then also 2 times that x. And then there will still be that operation in between them, which in this case was a minus inside of the brackets. And simplifying that, you can get 6 minus 2x. So that's what the regular distributive property is. Now with monomials, well, nothing really changes. We just have to be careful that we're going to be multiplying a little bit more complicated parts. So we start with what's in front of the brackets. In this case, we have to look at the full term, so the full 7x squared. That's going to be multiplying by the first part in our brackets, and then the second part in our brackets. So let's just be very careful. So we have 7x squared. That's multiplying by 3x to the 4. And then we're subtracting, because that's our sign. And then again, 7x squared, since that's the number in front of the brackets, multiplied by, in this case, the next part was the 5x. So we're going to write 5x here. Then we have to apply our exponent rules and ideas for multiplying monomials. So for multiplying monomials, take a look at the number in front of the variables. So 7 times 3, that's going to give you 21. Next, take a look at your actual exponents and variables. So you have x's, so they can be combined. So x squared times x to the 4. We're multiplying things with the same base. You add the exponents. So you'll have 2 plus 4, which is 6. Okay, what about the next part? Well, the next part, take a look at your coefficients. You have 7 and 5. So 7 times 5 will give you 35. And next, you have x squared and x. Just remember, if you don't have the exponent, it's like there's a 1 there. So when you're using your exponent laws, you're adding your exponents. 2 and 1. 2 plus 1 gives you 3. And there we have our answer. So you might be tempted to try to combine these two, but remember, you can only combine them, like we just did, if we're multiplying the actual terms together. So that's why we're able to do that on the left and the right, because those two parts are being multiplied. But this final part here can't be combined or can't collect like terms, as we've said in the past, because the individual parts, the x variables, have different exponents. All right, and that's a look at that particular problem.